And the last topic we're going to talk about in section 3.3 is going to be condensing logarithms. So going in the opposite direction that we were just on the last video where you were expanding, now you're going to be condensing back to one logarithmic expression. Okay, so the directions say use your properties of logs to condense. Write the expression as a single logarithm whose coefficient is 1. Where possible, evaluate logarithmic expressions. Coefficients of logs must be 1 before condensing them using the product or the quotient rules. Okay, so as I look at number 10, the coefficients of both of these are already 1. So I'm going to look at how they're related. We're adding, so this is the opposite of the product rule, which means I can condense this to 1 log of, it would be base 10, of x times 7, so we would just write that as 7x. Okay, then if I look at number 11, I have a coefficient here of the first term, 5 times the log base b of q. So first I would want to rewrite that as log base b of q to the 5th power. So we're going to use the opposite of our power rule to get my coefficient of 1 here, minus log base b of r. So now that I have a difference of 2 logs with the same base, this is the opposite or kind of the reverse of our quotient rule. So I could write this as a single log, which would be log base b of q to the 5th over r. And again, we can't simplify any further, so that would be as far as you can condense. Okay, number 12, we have natural log of x plus 7 times the natural log of y. So first thing I'm going to do is use my power rule to rewrite the 7 times natural log of y as natural log of y to the 7th power. So again, if it is addition, this is going to point you to your product rule. So this would equal the natural log of x times y to the 7th. To convert this to condense to one logarithmic expression. Okay, number 13, I have 1/6 times log base 4 of x plus log base 4 of y. Okay, notice it's 1/6 times in parentheses, so we know we could distribute that 1/6. Okay, to each one of the logs. Then use the power rule. So I would have log base 4 of x to the 1/6 plus log base 4 of y to the 1/6. And so if it is addition, if we're adding, we can convert this to a single log base 4 of x to the 1/6 times y to the 1/6. There is a simpler way now, since both of these are raised to a rational power. We can convert that to a radical, so it would be log base 4 of the 6th root of x times y. So while this one is correct, you would need to take it one step further just to get it as simplified as you can. Okay, and then number 14. This one looks a little longer. Okay, I'm first going to look at just the first half. Okay, I have log of x plus log of x squared minus 196. So if it is plus, if I'm adding here, I know that I can condense this part to be log of x times x squared minus 196. Okay, because we're subtracting, this means I would have a quotient. And notice both of these are being subtracted. So just think for a minute, if I were to come over here to the side, if I factored out a -1 from this amount, it would give me log 7 plus log of x minus 14. So kind of think about it in that terms. If I'm factoring out that negative 1, that by having that subtraction, it means I'm going to have a quotient. Okay, so then because now these are being added, it's going to be a quotient, and then I'm going to have a product also in the denominator. So I've condensed it to 1 log of x times x squared minus 196 over 7 times x minus 14. Okay, then always look to see if you can reduce. If I have this binomial in the numerator, I can factor that. That's the difference of 2 squares. It would be x plus 14 times x minus 14. And then x minus 14 would divide out, so I would be left with log base 10 of x times x plus 14 all over 7.